Good morning. This is the John Chappell Natural Philosophy Society Science Chat, and today is June 17th, 2017. My name's Franklin Hu, and I'll be your moderator. And today we've picked a particular topic of J. William Hooper's paper, New Horizons in Gravity and Magnetism, I believe. So let's go ahead and put up his paper here. So this was brought to us courtesy of Bill Lucas, who sent a link to this. So I believe, so Ian, you said you had some specific points that that you made while you were reading this paper. Why don't you go ahead and share with us what you think?
Well, I hope I do justice to the detail of the paper, but perhaps I'll mention, if you like, these 6 or so points, Franklin, that I gleaned out of the paper. The first was that the Lorentz electric field obtained as a result of the V cross B term is not electrostatic. That's what he's claiming. It's normally considered to be an electrostatic field E, but it's not electrostatic, and therefore it is not subject to shielding, a Faraday cage type shielding. He demonstrates this by experimentation. And he says that during the Second World War, he was experimenting in planes where they were cutting the Earth's magnetic B field with velocity v, and he was measuring the electric field and therefore deducing the speed of the aircraft. And of course, the metal cage of the aircraft did not shield this E field. So it's not electrostatic. That's the first point. The second point, which struck me, was that he talks about the Faraday magnetic induction law, and he distinguishes between flux cutting and flux linking. He says these are frequently confused, and he says they are two separate things. Basically, the induced electric field is the negative of the differential of the flux. He calls it N, and as that's basically the magnetic induction times the area, if you differentiate that, you get B times dA by dt plus A times dB by dt. And he calls one the flux cutting and one the flux linking. And you may have one without the other, or you may have both.
Now, does that make sense to you? I mean, that's kind of how I read it, but I really didn't understand what he was talking about. Because you've got flux, I kind of understand that, and you've got flux cutting, I can understand that, but what else was we talking about?
Yeah, okay. That didn't come too much surprise to me, at least. Just wanted to maybe add this. So actually, it turns out that there is no induction without cutting of lines. In particular, Faraday's law of induction doesn't apply if the loop is situated in the homogeneous magnetic field that is both outside and inside the loop, you know. There is no induction at all. So actually I've been prepared on that part based on the kind of stuff that I worked before, and I came with these things some 10 months ago. So I hope at least I could bring it again and somehow relate to some other works as well.
Well, I understand.
If you boil down to the linear magnetism, to the non-zero divergence of A, those kind of things. Just so, but this distinction between the line cutting and how was the name? Flux links of flux changes so on, is kind of relevant. I mean, and okay. should be looked in that way regarding the problem with the basic law, of partial derivative of B over T instead of full derivative in general. Okay.
Well, I understand that if you have a magnet and you have a wire, if you just stick the wire in next to the magnet and don't move it, you're not cutting any flux lines and you're not generating any electricity. Now, if you sit there and you wave that wire around the magnet, then we do start seeing a electric flow through the wire. So that's how I normally understand it, and that's flux cutting. But I don't understand what flux linking meant in this.
Flux linking is kind of time variation of magnetic flux, like between two solenoids or in transformer, and that's that mechanism, kind of the basic Faraday law of electromotor force induced by time variation of flux.
Okay, so maybe it's if I have
mutually between two circuits or whatever, right? Or between magnet and circuit.
So would it be if I have a solenoid and I'm varying the voltage in that solenoid
and current,
and I put a wire next to that, then we will also see a current flow in the wire due to the varying magnetic field. So is that what they mean by flux linking then?
I think that's what he was trying to get at. Now, I have an open mind on this. One is the variation of the area, which is actually cutting, if you like, the lines. The other is the variation of the field itself. Now, maybe we should call both flux cutting. I don't know about that. I mean, using another term, maybe a bit confusing. Alf Kelly performed a lot, redid a lot of these experiments of Faraday. And he establishes in his book, Challenging Modern Physics, that you must cut the field in order to get an EMF. So it may be a question of terminology. I don't know. I have an open mind on the question.
Well, I mean, that is an interesting point. If you're varying the magnetic field strength, is that really cutting anything? It wouldn't seem like it's cutting anything. I mean, not unless the magnetic field lines move in and out.
Yeah, actually, in practice, you always seem to have that kind of process. It's not kind of visible, kind of, but you people just get complacent and satisfied with what they get, with some kind of basic agreements. But when one enters more deeply into the issues, for example, the kind of in the transformers, those losses and things like that, then one gets more deeply into that and starts realizing there might be some problem there. But let me at this point mention just very end of this book. I mean, before the appendix part, he's talking about two mechanisms of induction of electromotor force without presence of B. I mean, without presence of the curl of A, right? One example is the wire situated vertically to two magnets that are positioned on both sides of it, and the current or electromotor force induced in the wire, although B is 0. And the same thing if you have two solenoids, one inside the other, and you put the current and voltage into the one inside. There is no field B outside. There is no circulation, local circulation of whatever of A. But still, you get the electromotor force generated and current present. So this is very, very, instructive and very, very, remarkable. And that will be maybe something to think about. I mean, so here it doesn't matter. You change the current, you change the B, kind of, you change the flux or change the vector magnetic potential, but the B's are zeros in both cases. But still, you get effects.
What do you mean the B is 0? I mean, The B being the magnetic field. I mean, that's certainly
Yeah,
not zero.
but magnetic field that comes as a how say measure or effect of the curling of vector magnetic potential.
No, I don't
That
understand.
part becomes cancelled, and something has to be there to produce that effect. And and I can mention it again. So I've been pushing for that divergence part of A. So the divergence part of A actually kind of convexive part seems to be related to that effect and essentially responsible for the generation of electromotor force in conventional facilities of generating the current, right?
Well, I'm just saying I don't understand the example you gave. If you stick one
If
cylinder,
if you go to the very end of the article, just show to those two magnets and wire between them. You go just to the last section or maybe end of that before the appendix part.
Well, the thing is that those pictures don't show any situation where there would be zero magnetic force.
Yeah, but it is. You see that B's are kind of counter in the counter directions, and you know that there is no how say officially in electromagnetics, and it has been in physics for quite some time. Is known and kind of agreed on that there is no B outside of the solenoid, right? But Arachon and Bohm predicted that some force should be there, and they checked for it within the slots experiment, and they confirmed that. So here in this part, he first shows this example. So here the wire is situated between those two, just in the middle, and going into the paper, right?
Yeah, but any wire stuck there would be drowned in magnetic field.
Okay. But look, the directions of B's here are counter each other, right?
Yeah, but only in certain, probably only one very small spot in space would it be canceled.
The line forces. So the measure of curling of vector magnetic potential are going against each other, but the circulation is not going. The circulation is actually the actual flow. The actual flow is being superposed. I mean, this is very important. I mean, this experiment and this next one, the next one, as I said, is totally directly related to the Arachonov-Bohm prediction, and that's confirmed that there still is force, some flow of energy outside of the solenoid, although the curl of A that is supposed to produce the conventional B field is zero. And here it's very interesting. When you take just one magnet, you get half of it. That means actually that the only effects, the effective mechanism is actually that one that this guy Hooper seems to have been first to come up with a long time ago. When was it? Back in 56, right? I know three authors. So Gennady Nikolaev, the guy Sigalov, and Atyukovsky also. Atyukovsky is in his formulation of electromagnetic equations. He has that situation where B as curl of A is zero, and still electromotor force is produced.
Well, I'm just having a hard time understanding what that meant.
Yeah, so I mean, in the formalism of solving the Maxwell equations, conventional Maxwell equations, right? People have started involving two potentials: scalar potential and the vector magnetic potential. And in that way, with the Lorentz kind of condition, gauging condition, they separate these two equations into two equations, one to be solved on scalar potential and the other to be solved on the vector potential, A, right? And then they proceed by that, and then actually, like A becomes as a time variation of E becomes time variation of A, and the B, a magnetic field, becomes as a curl of A, right?
Well, what's
And
the A and what's
A is a
what's
magnetic
the
vector
curl?
potential, right? It's something that is related to the current, for example, in the solenoid, or velocity, charge, and velocity of some particle. That's magnetic vector potential. I mean, A, usually denoted as A.
Yeah, I'm not familiar with A.
Or you should then you should all guys you should just get back to those things, you know. I
You
mean,
might as well be saying X.
Well, Franklin.
you know, my point has been since long, you know, when they're talking about Katz's question, that experiment and some other things. I was exchanging emails. I forgot with David, you know, and I was suggesting and referring to these guys like Gennady Nikolaev and Tchaikovsky, that actually the divergence of A is not zero. So that part actually contributes to that kind of shape of the B field lines that go around the conductor, which are not contained only in the planes perpendicular to the conductor, but that flow goes kind of helicoidally, and that longitudinal part of the flow seems to be this V times B, V vector product by B of Hooper.
Well, what
And
is that?
it is called a second magnetic field of Kolya-Sibirsky and so on and so on. But Hooper seems to have been first one to come up with that.
So, well, getting back to Ian's first point, which is this B cross V. So they're clearly showing this in this figure 7.1. It says pure B cross V field. So they're talking about the magnets, the V being referring to the motion of the magnets. That's what he's talking about.
That V, yes, that V vector product with B actually is collinear with the conductor. The conductor is at this point in the middle, so going straight into the page. So that so-called electromagnetic electric kind of field related flow or whatever seems to be actually that part
well, this
that
is
generally is collinear with the conductor in which the current exists. So that's the longitudinal part. So currently in the physics, you know, all the time, only the magnetic vector field, which is a measure of curling of that kind of quantity that has been considered still as a hypothetical, which actually should be that the energy flow that we've been talking a long time ago, right? Primacy of energy over matter and vice versa, you know. Actually, that is kind of that flow, the rotation of which, the curling of which, is measure of the conventional B field. But in addition to it, there is the longitudinal part that is kind of can be related to the divergence of A. And you know, all the fields, starting from Helmholtz, how he defined it, are to be defined by two quantities. Two, derivatives. One is the special derivative of rotor kind
let's stick with,
of A, and the other and the other by the divergence. You know, by those two quantities, all fields are defined. unless you go to potentials, and then from potentials you get to those fields.
I'm just trying to understand what Hooper's trying to say in this picture here. Now he's saying, note that the wire is always in a region where B equals 0. Now he's talking about a wire between these two moving magnets. Now, first of all, I would disagree with that.
The wire enters the page here, right? At this point in the middle.
Okay, so the wire
vertically to the page.
The wire is poking out of the page. Okay, I didn't understand that. That little dot is the wire poking out of the page. Okay, so that's one thing to understand. Now he's claiming that the B in that wire is going to be 0. Is what the claim is.
Well, can you say that?
But actually, he may not be quite correct here. You know, there are some. Okay, one has to have. He had to have some interpretations and so on and so. But maybe in certain how I say conceptions and so he might not have been right. So let's see. Here, what is more obvious actually would be that those lines, magnetic line forces, are hitting each other, right? So it would be actually. But anyway, no. Okay. Here he has B times V, and then both of them by minus signs, right? So they are collinear, right? So the effects that are produced by this vector product are collinear. I mean, in same direction. They add each other, right? And on the other hand, that he indicated with B equals 0 is actually the fact that these B lines, only the lines that have been shown here only, they collide each other, and thus they have cancel each other.
I don't know about that.
Yeah. Okay. So in this figure, is shown the situation B equals 0, and something that is not visible here except this dot is that superpositions of the B vector product V of two kinds, one coming from one magnet, the other from the other magnet. You know, both having different signs from the previous one, and thus being collinear and in same direction.
The result of this experiment is that if they say move both of the magnets, they get twice the voltage they would get if they say only move the right-hand magnet.
Yeah, that means actually, as I wanted to say, that the net effect of such process or conventional electromagnetic induction is just seems to be related only to this effect, and the other effect, the overcoming of the lens force, comes something like really in vain, kind of.
Well, I just don't find that.
He's also saying that reciprocity breaks down. When you compare the situation whether you move the conductor on the one hand or you move the magnet on the other, because in the first case you have an electric field generated either by cutting or linking, whatever you want to call it, of the lines of force, and he claims that in that case that field will be shielded by a metallic enclosure. But in this case, where the magnets are moving, and
he actually considers there is no difference essentially, I think, here between these two cases, like moving magnet or moving conductor.
Well, he is saying that if you move the magnets, you get this Lorentz field, which is not shielded by a metallic enclosure. So it's different in nature.
Yeah, no. He has been talking most of the time about the moving conductor, right? And then he actually was arguing that there could be some kind of electric field inside the cage, inside some metallic pipe. Although based on conventional theory, there should not be such a field there, because that field would be induced into the shield, so that that field should be annihilated. Things like that. I mean, that kind of discussion he has been proceeding with from the very beginning and so on. And at some point here, he switches into the complementary configuration, where essentially he doesn't differentiate between the movement of this or that, conductor or magnet, and then from that point on, he actually does not differentiate. It's also in terms of this kind of expected zeroing of the electric field inside the cage, inside the pipe, the metallic pipe.
He says, but here I'm skipping to the very last point, and we haven't talked about gravity yet. He says that there's an apparent conflict with the special theory of relativity insofar as it is normally interpreted by relativists. But he said, actually, properly interpreted, there isn't a conflict. However, he says there appears to be a conflict with the general theory of relativity. That's the sixth point I was going to come from.
No, you mean with special theory of relativity. Actually, he has been using the special theory of relativity and the transformations that are used there, and kind of even, obsoleteness of magnetic field and so on. And in that context, he comes also to some kind of indication that that what he has been pursuing might have some reason and so on and so on. But in general, I mean, Einstein has mentioned first thing that he mentioned in his work, right? One paper, 1905 paper, was that kind of non-equivalence of two situations when conductor is moving and magnet is fixed, and the magnet is moving and conductor is fixed. I mean, where it came from and why and so. Actually, I don't know, to some extent might be based on just kind of the B field, the curling of A and so on and so on. But it turns out in here, in this experiment, that doesn't matter. That's kind of very kind of unnecessary and kind of obsolete to rely on that. Although he kind of used those transformations to come to some conclusions, to some indications.
Well, yes, I was just reading the explanation. Now, Hooper is saying that the expectation in this experiment is that you shouldn't be able to measure any current in the wire because the magnetic field has been theoretically canceled out in the position of the wire.
You mean here, you are talking about figure 7.1, right?
Yes, 7.1. I mean, the prediction is that there shouldn't be any current flowing in this wire at all because the magnets are facing in the opposite direction, and therefore there shouldn't be any current flowing. But we observe the opposite, which is that twice the current flows if both the magnets are moving. So his point being that whatever is causing the induction doesn't have anything to do with the magnetic field seems to be his primary conclusion.
Great. With the magnetic field of conventional type, that's kind of the B that is results of curling of A. So measure of amount or whatever, intensity, whatever, of that A kind of potential flow. So essentially is that. That's very, very interesting.
Okay. So
once here, everyone would expect, if you take out one magnet, you get what you get, and you explain it by B, and cutting the lines of B lines by the conductor, or vice versa. And you put the other one, you get 2 times effect. Oh, just fine, right? But at once you realize that B that you have been relying on is 0. How come? Something else should be there, right? And essentially, the only effect, netto effect, useful effect, is that one that comes from V vector product by B. Whether it is that V of the electrons inside the conductor or the flow outside of conductor, that's another issue. I would opt for the later one. But we have discussed that some time ago and things like that. So at least I have insight and expectation. If you will enough patience, within this group, we will really come to kind of really situation where we would be able to understand everything. All those aspects come up to some basic mechanisms, and then
Well,
explain everything from here to the Kat's question and whatever.
Well, what's surprising me is I think due to the opposite arrangement of magnets, that the electron flow would be driven in opposite directions. So during this experiment where the flow is twice as much, what direction is the electrons flowing?
Yes, so electrons or something outside the conductor. I would opt for the later one. Actually, is flowing of some substance, some energy outside, mostly outside of the conductor. Okay, even if they are inside the conductor, these such situations that will be semi-directional.
Okay, so some mystery here that Hooper is pointing out.
So
let's get back to
can I tell you something here? Hooper is talking here about some ways to produce energy. So he mentioned that the Morey guy, what he did actually, he was avoiding the lens effect in line with Tesla's magnifying transmitter. But regarding this, what Hooper has been pursuing and come up with, there is a community in Switzerland. The guy who was actually the watchmaker succeeded in producing the mechanism of this kind, the so-called cast statica. They have very efficient generator for electricity without any effect of Lorentz kind, and actually with positive feedback, where actually one has to time the system, not to get out of control. So those guys are producing the electricity based on Hooper's insights. Maybe unknowingly, I guess unknowingly, but again.
Well, let's get back to Ian's list. So Ian, we talked about the B cross V, and
okay. Just before going on, just mention one thing. Mathematically, he points out that since V cross B is equal to minus B cross V, if you subtract the two from the opposing magnets, you get twice V cross B, as indeed you said earlier, and we're trying to look at that physically.
Yeah, but B is zero. That's the point. The B is zero, and some other things is not zero, and then some other things has not been considered at all in the electromagnetics and physics, except Arahonov-Bohm experiment. And everyone in electromagnetics community just close the eyes at the fact that although there is no B outside of the solenoid, if the current in the solenoid changes, it gets induced electromotive force and current in the solenoid outside, situated outside of that very solenoid. So situated in the space where there is no B, but there is something else. And the something else is this kind of flow.
I think that's probably the question of whether by superposition those magnetic fields are actually canceled like that. I mean, it looks like it may be canceled by your plus and minus signs, but I would not be 100% convinced that that's what's going on.
Yeah, but if you take it as superposition, one is the measure of rotation. When you have some flow, say helicoidal flow of fluid, right? Then you characterize that flow by the measure intensity of rotation. So angular velocity of those particles, right? And you calculate them, measure them, whatever, and you assign to a very small area of that fluid some quantity you call, I don't know, flow, whatever. Here you call it B as intensity, But that's kind of a representation. But in that representation, if you divide that, you get that actually they can cancel because algebraic, the one is plus one, the other is minus, But if you take into account that the same thing you measure kind of amount of rotation of the fluid, there is the rotation itself. There are some other mechanisms and some other dynamics inside that fluid, and that dynamic can be kind of longitudinal type. There is some kind of change of density or whatever along the side, along the or perpendicular to that previous direction, and here along the conductor.
I think the flaw is that in looking at Hooper's picture there, he has a balanced magnetic flux density lines, and in fact, the lines of force that are going between the North Pole and the South Pole and through each other's magnets are much denser than he shows, and so the primary flow of magnetic flux is in a counterclockwise direction, and the electron is not just contained within the wire. The electron is the entire field.
Yeah, great. Yes.
Around the wire. So
yes.
basically, the overall flow of the field, as far as the electron is concerned, that it's feeling, is in a counterclockwise direction. So if you put that picture back up of the flow, you'll see. If you were actually to put two magnets down and you looked at the iron filings, you would see that the lines of flux density were much more intense going around in the loop. If you see there's one line going through the center of each magnet, that line is actually representative of a much more intense density than the other lines. And
yeah,
so
okay.
Instead of one
the
line,
situation is totally symmetric or anti-symmetric. There is really there should not any impact of because we have total symmetry or anti-symmetry, right? This here kind of anti-symmetry in terms of this kind of curl of A or conventional B, right? But
right.
There's kind
of primary flow when you get these two magnets together is going to be in a counterclockwise direction, where you have that complete circular flow in that the one line that crosses from left to right, where they don't oppose each other, or where they don't oppose each other on the bottom and where they don't oppose each other on the top. That line is actually a much denser line of flux than any of the other lines. And you'll see that if you put iron filings on a piece of paper with a couple of magnets orientated in that direction. That, because it is the densest area of flow, is what the electron primarily senses. Because, like I said, the electron is not just that simple, is not contained just within that simple dot in the center of the wire. The electron's field actually extends out beyond even the magnets. So the magnets are within the rotational field of the electron.
I would rather be talking about the structures outside of the wire that kind of experience, right? So rather but we are talking here about symmetry and asymmetry in terms of conventional B and the other kind of B that Hooper has come up with, So if we would change the situation here, right? Turn around the other magnets, then we will be different situation. Then we would have been something kind of the V times V would be 0. I mean, would counteract each other, and the other component would be non-zero, right?
Yeah, there would be no rotational characteristic to the entire field.
Okay. So in this situation, there is no effect of rotational characteristics or amount of the fluid there. But in this situation, but there is the combinatory, or superpository effect of the other kind of flow, right?
I'm not sure I'm following that.
So my point is here. I mean that whatever field is, vector field, force field, can be separated, decomposed into two, or defined by two quantities. One is the measure of rotation of the elements of fluids, in certain areas and certain loops, and the other is kind of change of density of it.
Right.
So the one is curl of some quantity, the other is divergence of some quantity.
Right. And
conventionally, we have been talking only about curl. This guy indirectly came with something that is called divergence, and some other guys after him, without referencing him, obviously without knowing anything about Hooper, these Russian guys, the Sigalov and then Gennady Nikolaev and then Lazukovsky, right? They come up totally almost independently to this conclusion. And on the other side, in the physics, they have realized that besides the vector magnetic field, that is amount of circulation of some even kind of hypothetical quantity, there is also something else, you know. And that something else is something that this guy has been indicated quite much earlier, you know. But those things in physics stay kind of unknown to other guys, and even not to physicists themselves. Although they're implementing containers for plasma based on that field, you know.
Well,
So
basically,
I'm sharing this with you because I kind of got into that domain for quite time, maybe one year now, and kind of, I mean.
Okay.
Well, I mean,
so here we have a situation that conventional field cancels and there is no effect, and the other one has effect. And in other, in addition to that, it appears that actually the main effect can be just that one, the one kind of, because he doesn't show here what would happen if we would turn around this magnet, one of the magnets, whether there will be induction at all.
Well, they don't really cancel
because
in this image. In the image, they seem to cancel, but they don't really cancel because, like you said, it's not showing the density of the flux lines. It's just showing the general direction.
Yeah. So yes, my point here.
And the density can be shown by using magnetic.
Sure. Great. So
iron filings.
So vector algebraically they cancel. One is plus, the other is, so one curl of one is plus, curl of the other is minus, right? But there might be something else there that adds constructively. So that says that was something of the process itself. His distribution of density, the change of density, gradients, and so on, right?
Well, like I said, it can all be cleared up if you look at magnetic iron filings, and the magnets are orientated like that. You'll see the density change. Yeah,
but still you would see only amount of rotation, but not be you'd not be seeing the other part. Actually, there's a big problem because in general for longitudinal and scalar waves, there are no receivers for that. It's difficult to get receivers. Biological system seems to be natural receivers or kind of systems that work based on that. But technically, we have kind of. But okay. Technically, I mean, induction between two coils, between two solenoids, one outside of the other, and the current is put into the one that is inside. There is no B outside. Everyone will tell you there is no curling. There is no the measure of circulation or rotation is zero. So there is no conventional field. There is some other field. That's so-called the second field of Kolya-Sibirsky. What this guy came up with, and this guy came up with, with this based on kind of first starting with electron in magnetic field and so on, and then generalizing it into the sets of electrons inside the conductor. But there might be kind of misconception. Actually, net effect and the true effect could be actually maybe related to the process outside of the conductor in the at the substrate and the flow of energy there. Right? Yes, thank you.
I appreciate your enthusiasm, but I encourage you to take a few breaths so that other people can get a word in edgewise. Also, for some reason, your microphone seems very loud. I was wondering whether you could turn it down a tad, because you're coming in much louder than everybody else.
Okay.
But to respond to Cornelius, I don't think that the density really matters that much, because no matter how dense the field lines are, no matter where they are, they should be oppositely oriented and should be equally canceling. I think it's Hooper's point that, no matter where the density is, not unless you can show some place in this diagram where the arrows are not canceling, that it just wouldn't matter what the density is.
What is important here?
Just put together magnets and put some iron filings on it, Franklin, and you'll see the density yourself.
Yeah, but the densities cancel. It doesn't matter how dense.
No. May I suggest something just to you all? Besides of these lines here with those arrows, to imagine some lines going around them, right? Around them, and you will see then in the same direction in terms of kind of if you put the whatever thumb in the arrow direction, and then you have the fingers and so on, and then you look what happens with those flows that correspond to those kind of circular helicoidal flows around these lines shown here. You know, we would have different situation when we look how those two lines, those two flows relate to each other.
And well, let's go on with Ian. Ian's got his list of his points, so I'd like to see what else he thinks he's found out in this paper.
So it's up to you, Franklin, as moderator, to decide whether we deal with each of these points as they go along, or maybe hear the lot of them and then come back. Maybe, as you've been doing, a compromise is to have a short discussion on each one and then maybe go on. Because he then looks at gravity, because his whole conception is electromagnetic fields and the gravitational force. And he maintains that the gravitational force, and I know you yourself have looked at this in maybe some analogous way, he says the gravitational force is no more than the difference between the push and the pull of convergent and divergent B cross V fields acting on electrical constituents of atoms. So it's sort of a neat way, again, I have an open mind on it, but it's a neat way of indicating that the gravitational field is basically no more than this sort of Lorentz type force, which is imbalanced.
Yeah, this is one of his main points where he seems to be very excited about perhaps he has found the source of gravity as being these motional magnetic fields. And he's basically saying that because, well, these motional magnetic fields can't be shielded and gravity can't be shielded, and therefore they must be the same thing, which seems a bit of a leap to me. I mean, they may have that in common, but that seems to be an awfully large leap. And also, I see we have Pal with us. Hi, Pal. I see that, but we have your video on, but it's very blurry. And if you're not speaking, we could just turn that off. That would be less distracting for us. All right, Pal, thanks. Okay, I'm not sure you heard us. But I mean, that's my first reaction to that, which is that the only thing he has in common between gravity and this motional magnetic field, that's a little bit of a leap. Now he does go and show that, for example, around a hydrogen atom, you know, he's thinking that the magnetic field is being created by, say, the orbiting hydrogen atom, and so that would be, for example, the source of the motional B field. So I suppose that's one way to explain it, but then again, you would have to explain all the problems that we have with electrons orbiting atoms. But I think that, you know, Bill Lucas, he has his spin on that, and that they're not orbiting, they're just vibrating. It is another solution around that to give that kind of motional field. But
yes.
But other than that, I think you need better evidence that that is the same kind of field.
When you use conventional electrodynamics and you calculate the net field or force exerted between atoms where the electrons are vibrating with respect to the nucleus, like dipoles or other types of multipoles, you find that since they're spherically distributed, there's a certain amount of cancellation, but you have a net force, and it's a 1 over r squared force, and it appears to have all the characteristics of gravity, and but there's two terms. There's one over r squared term that's proportional to the regular Newton's gravitational force, or Einstein's general theory of relativity in non-relativistic form. But the second term is very important because that term enables you to explain the motion of the outer spiral arms of spiral galaxies, which neither Newton's law of gravity nor Einstein's general theory of relativity can explain. But in order to try and cause those theories not to be falsified, they invented dark matter and dark energy as a fudge factor. And the fudge factor is that dark matter and dark energy represent 96% of the universe, and the observable matter and energy represents 4%. So it's basically a fudge factor of 25. And but that isn't needed if you use the electromagnetic force between vibrating multipoles as the origin of the force of gravity. And so that's what that's that term that doesn't cancel out of all the forms of the electromagnetic field that can exist when you have vibrating electrons with respect to protons. So the work of people like myself and also chemists have shown that this is in excellent agreement with what we measure in the laboratory. The problem we have is that the current scientific method won't allow this to be considered politically correct science. In other words, they want it to be the way it is, not the way it should be. And they don't allow the use of logic to falsify their theories. So that's why it's perfectly fine to invent a fudge factor called dark matter and dark energy and have it 25 times bigger than the observable forces. That's fine, and you can't falsify a theory based on these types of assumptions because they're not true.
Well, what I found interesting was that this paper was published in 1960s or something like that.
74.
It's not that recent? Well, 74. Well, that was
no, it should be
recent then.
should be earlier. Actually, this is kind of reprint, but the original is very old. I mean, kind of.
It was 1969. Well, there was some earlier work, obviously, some years before that, in the early 60s and so on. But he died in 1971. I seem to have gleaned from the paper, and there was a couple who were putting in some financial support. And the lady, a few years later, maybe around 1974, wrote one of the appendix articles, just summarizing some of the results that they had done.
Yeah, well, that organization there that it shows on the beginning of the paper or the book, it shows that this couple financed this organization called Electrodynamic Gravity Incorporated, and Hooper was the principal investigator, and the wife of this couple was kind of like his laboratory helper, and so that's they were named Gibsons, Mr. and Mrs. Warren Gibson, and she carried on the work for 1 or 2 years after he died and published a few papers. But now she's in a mental institution from very old age, and her husband has died. And so...
but they reprinted it into latex, actually, this form. The graphic form is totally new, so...
Yeah, the paper has been redone very nicely. I was wondering, how does this relate to the paper that you're working on, Bill? Is it going to be similar to this one, or is it a different book?
Oh, my book is what's in this book, plus a few more papers related to patents that were filed. So there was an earlier version of this. First of all, the book was never printed in a normal printing press. The book had been typed and then Xeroxed. And then put together with like a plastic comb or something like that. And so that was the way it was originally done. And I had a copy of the Xerox of it, and so I used that, and it was very poor quality, the Xerox. And so because it was done when Xeroxing wasn't that
But
good.
it is going to be about the same kind of
material. It's the same material. The diagrams, they redid the diagrams because they were so poor.
Yeah, 'cause I thought that was a really, really good job that they did on this paper as far as, formatting and the diagrams. And
Yeah, well, the diagrams that are in color, they added. The ones that aren't in color were the ones they took from the original document. And my copy of the book is a little clearer on the ones that are still in black and white. And but they're the same. They were coming from the same original. And but what I have is more of the papers that this lady did, who was his partner in the laboratory, and so you have a little bit more information. But basically, uh, I would say something like 109 pages of the original, which they have as more pages in this copy, but I put them together more condensed, and is the same, and then the rest is just additional papers that were relevant that were done by either Hooper or his laboratory partner.
now,
And
my comment about this relationship to gravity. So, in this paragraph that I'm showing here, he's saying that should success follow, that we would get free electric power from the Earth's gravitational field, and we could visit the moon and the different planets. We could have gravity-free laboratories, and infinite possibilities. But if all of this were true, and it looks like he had actually built some of these devices, then, where's my flying car? So, I mean,
well,
that kind of tells me that no matter what's in this paper, it couldn't possibly be that right? I think we would have flying cars by now.
You got to look at this paper differently. This paper is showing the experimental results, which can be reproduced by anybody in their laboratory if they have the right equipment. And he's showing it's not fully compatible with our theory of electrodynamics. That's what he's showing. He's speculating on these other things. He doesn't have any of them built and that sort of thing. He did do some what you might call magic tricks that looked like you had some of these things, but and other people have done those too. But anyway, that's not what we want to talk about. I don't think. I think what we want to talk about is what did he show? And basically, he showed that the version of electrodynamics that's built on the vector potential A and the scalar potential phi is not valid. It's partially valid and partially correct. It predicts some things, but there's other things it misses altogether. And one thing it misses is these three types of fields. There's only one type of field as far as the vector potential approach. And the work that I've done, I've shown that we should never have used the vector potential approach at all. We should have used the energy potential, which is not the same thing. The vector potential has nothing to do with energy or conservation of energy, but the energy approach has to do with conservation of energy. And when you do that, you get a more complete version of electrodynamics from the empirical laws of electrodynamics than you do with the vector potential approach.
Now, I see Cornelius has raised.
Okay, maybe just for record, because I was talking much about that before, because about A and the curl of A and divergence of A. My point here would be actually, just to summarize, would be actually that instead of using the Lorentz gauge condition, where divergence of A is 0, actually divergence of A is non-zero, and then based on Flandren's electrodynamics, you define something as Bill mentioned, something like scalar field, S field. S equals 0 actually, out of which over the through the Lorentz factor you get actually all these things like non-zero divergence of A and so on and so on. And regarding the gravity and this kind of emotional magnetism or electric force, whatever, is for me is quite compelling. Although I would approach it rather by electric and magnetic components of toroidal flow of energy and so on. So that can be directly fit into the kind of just extended Newtonian gravity and orbital motion with addition of 1 over r to the squared, to the third degree force and so on, anti-gravitational and so on. Okay, thank you.
All right, Cornelius, did you have a comment?
I was going to go back to where we were originally starting with Ian and the electromagnetic field being summarized to create gravity. And I think that kind of relates to what we were talking about. Maybe it was a week or so ago, where we were talking about the magnetic monopoles. And so basically, the electric field, in my view, is still a polarized type field, and you really can't cancel that field no matter how you put it together. You always get the polarization characteristic, just like when you were showing several magnets put together to try to make a monopole. You always have a way for the North Pole field to turn around and reach the South Pole field. So there's still some polarization characteristic to that. And I think Ian had a document or paper that he wrote probably a year or so ago, I don't recall, where he was talking more about a sound wave or a longitudinal type wave and being divergent and convergent. And it might have been relating to sound and equating that sound wave characteristics to like a light. But to me, the longitudinal and type wave just radiating out from a point or radiating inwards to the point, the circular characteristic or spherical characteristics of that longitudinal wave is monopole type characteristic and would be a much more adequate description of how a gravitational field would be communicated is through the longitudinal characteristics rather than through the electromagnetic polarization characteristics of transverse waves. So basically, I think I see that the field, the same media carries the electromagnetic wave and the compressional or longitudinal wave, but they have different characteristics. One can create a monopole and the other can't. And gravity to me is a monopole type characteristic. It's strictly attractive, strictly in one direction.
If we think about anti-gravity, which definitely should be necessary to consider, then you can think about.
No, because there is no such. You can think about anti-gravity, but there is no such thing as anti-gravity.
Yeah. Then there is Then there is dark matter, dark energy in this case, right? Dark matter for attraction and dark energy for repulsion, right? We would rather think about attraction and repulsion of electromagnetic type, maybe in line or with some modifications, of course, what Hooper did, and proceed that way. Not to stick to just one force. There's just one force. There is no one force. Yeah. Otherwise, you have dark matter and dark energy, right?
No, I don't hold dark energy or dark matter, but I also don't hold.
You have to postulate it. That was my point in line of what Lucas was talking, right?
Well, you can postulate it, but there's no need for it. And there's no evidence of anti-gravity either, so I'm not going to try to...
I'm not for... Okay. In order to avoid the dark matter, dark energy concepts, you have to go for anti-gravity. Could you please tell us the name that you refer to, when you were talking about longitudinal waves and so on? What was the name?
The name of what?
Of the person that you referred to when you were talking about...
Well, that was Ian Cohen, who was speaking earlier. I believe he had a paper talking about sound waves and how they related to. Actually, I think he was trying to relate it to light traveling at the time. But yeah, there are other ways to explain the rotation of the universe strictly using gravity, or rotation of the galaxy strictly using gravity. Somewhat like Bill, like Bill is saying, they are bringing in dark matter and dark energy because they don't understand how the fields we do have really work.
I mean, I think it's interesting. You think that gravity is like a monopole. You think it's all attractive. Although, how do you explain what a helium balloon does?
Okay. May I suggest something before that? Okay. May I tell you something, please? Okay. I some time ago I came across an old book. I think it's Gibbs books. Gibbs, that guy who, came, what was it, before Descartes or whatever. He had a model of ball magnets of different sizes suspended on long wires, and that put next to each other and allowed to be positioned freely. They actually positioned into the solar system shape. I don't know about rotation, but possibly also he has gotten rotations and everything, you know. So that's very strong indication how one should proceed to the gravity and anti-gravity and its relationship and the unification with electromagnetic and so on. Don't you think so? Does anyone know for that book to recall the source?
No, I don't.
Okay.
Franklin, as far
Well,
as
a
the
couple
helium
of points
balloon
there.
goes, that would be just basically buoyancy, because if you don't have the atmosphere around it that the balloon is displacing, it will not rise. I mean, it won't rise in a vacuum if it's near a magnetic
Then what is buoyancy?
Buoyancy is basically the gravitational field. Gravitational strength is stronger on the heavier, denser atoms than it is on the lighter atoms of helium. So the heavier, denser atoms take their position closer to the source of gravity.
No, it's counteracting the Galileo's scientifically proved fact.
The same reason a bubble rises to the surface on water. The buoyancy, the water is displacing it. It's the same reason a boat floats. It's buoyancy. So that's what buoyancy is. It's not anti-gravity.
The key to gravity is that it is a force, and the force on a particular object, when it's immersed in a denser substance, is in the opposite direction as the source of gravity. So the force, no matter how you think about it, is actually opposed to the normal force of gravity. Now, you can call that buoyancy, and that's an explanation which I think satisfies most school children. But if looked at carefully, it's a little bit hard to believe. If I take a beach ball and I submerge it underneath the water, it's a little bit hard to believe that the density on the bottom of the balloon compared to the top of the balloon is what's causing the pushing. It's almost as if the air inside the balloon is being compelled upwards rather than you trying to shove all the water out of the way. But I'm just saying, I'm only putting that out as because this could possibly be one of those explanations which sounds plausible, but may actually not be. I'm just saying that the force of gravity depends upon the medium you're immersed in.
Okay, so now we have flying cars because
if I took a car and I stuck it in a pool of mercury, you would find out the force of gravity is upward, right?
Okay.
There would be an upthrust, which would be equal to the weight of the displaced fluid. So it's Archimedes' principle. But just a couple of points. First, the paper you referred to earlier, that will be published in a forthcoming edition of Galilean Electrodynamics. Now, there has been quite an amount of emails in recent weeks about this subject and transverse and longitudinal waves and so on. And I confess that I've had time to go through them all. But I noticed that in the last day or so, they've seemed to have petered out. So I'm not quite sure what the reason for that is. Another thing is I've pointed out before in some of the earlier maybe Baxter conferences that I use a system which is similar to Kelly's system for explaining the higher rotational speeds of the spiral arms of galaxies, and in fact also their nature, the spiral nature itself, by saying that we're not actually looking at one snapshot of all the elements of the galaxy at any one point, but actually as the galaxy is rotating, we're viewing at one particular time that we look at it with a telescope, say, different points of the galaxy, or sometimes the same points in different locations, and that if you sort of do a computer simulation of a sort of a spherical or ellipsoidal object rotating, you will get these spiral arms of galaxies. So I just point that out. That's another explanation, which of course vitiates the need for dark matter, dark energy, taking the simple Hubble type linear expression with
Well,
regard
I'm
to
sure we could talk about
different.
gravity all day long. So, but Hooper's point is whether the gravity is this motional B field. So,
Yeah.
what
So I'm
other
coming to
points
that.
did you pick up from the book? So, where
So,
that was the third
okay.
point.
So the third point here is that if he is right, um, well, then he extrapolates to the contention that you can negate gravity by introducing an opposing B cross B field. Um, Now, I'm not sure how far he's done this experimentally, but he talks about cryogenic generators, which could actually do this. And I think he has some incipient experiments of this nature. And he is saying that the sort of systems that we have for rocket propulsion using rocket propellant and escaping from the gravitational field of the Earth will be considered in some decades. He postulates to be very primitive and wasteful of energy, where you could negate gravity by the B cross B field. And furthermore, he says that for any gravitational field on a planet, you could tap into this for electrical energy because it's actually, inducing this B cross B, and you can get an effective free energy source from the gravitational field of the planet. So those
There
are
is already one, Test Attica in Switzerland. Please look at it. Stefan Marinov, Gennady Nikolaev, and Test Attica.
Marinov generator. Is that what you're talking about?
Test Attica. TESTATIKA.
Test Attica. Okay.
Can you put that in the chat? We could just look it up.
Sorry? Yeah, okay.
Write it in the chat and I'll look it up.
But I think you've correctly questioned this, Franklin. You've said if his theories are obviously correct, why haven't we seen these yet? So that's perhaps a valid question.
Ian, could I ask that you forward that paper that I was speaking about to me again? So I would like to look it over again, if you would.
That's Cornelis.
Yes, it is.
Yeah, okay. Actually, there's an updated version of it. I can.
That'd be great. That'd be wonderful.
Okay.
And I'd like to make a comment on what you were just talking about. The longitudinal EM theories. I came across a couple of papers by W.P. Wesley. Don't know if you've read his take on longitudinal waves and EM. He's actually done some experiments which supposedly confirms longitudinal EM waves. That's maybe another reference if you're not familiar with J.P. Wesley work. The other comment was, I was in a Galilean electrodynamics journal had continued. I thought that it fell away some years ago, and I've looked them up on the websites, and I really can't find a good reference to them for like back issues, how to submit papers, etc.
Okay. Here's Slobodan speaking again. So actually, in last year or two, I have been collecting and scanning all the issues, and of late, Dr. Whitney is sending me the PDF files, original files, so I can send you the link on my Dropbox, and I had sent it some time ago to the CPN to the group, where you can find all the documents, even in one file. Still not that convenient for searching, but it's searchable, but big file and so on. So it's not. So I can send it to you and to all. maybe now in the chat or what?
Journal? Is it an active journal? Or is it only the
It's still active, yes, it's still active, of course. It's still active.
website?
Yes, I was going to say the same thing basically, that maybe the website is a bit inactive at the moment, but it hasn't been updated recently. But the journal is still active, and as was just said, all the papers are available now, owing to this scanning in PDF form and so on, if you get that link. But actually, they seem to be getting a lot of publications because they're a little tardy in publishing. This paper of mine was first submitted to them, I think, at the beginning of 2016, and yet it won't be published until the later part of 2018, I think. That's the latest information I have. So they seem to have kept the information. But Dr. Whitney is coordinating.
Thanks. Franklin, thanks for sending out the Hooper book, and thanks Bill Lucas for providing it. I read through it. There's a lot of typos through it. I would really suggest somebody go through and correct the typos.
But very small typos, right? Very small typos, like is instead of in or something like that. That instead of then, and so on. So it's not.
Sorry, may I ask who was just speaking? You're asking those questions and typos.
Yeah, very small typos, I would say. So.
Yeah, but who was asking about the Galilean electrodynamics? I didn't recognize your voice.
Okay, my name is Slobodan Edic, actually.
The guy before that.
Bob Gray.
The American voice.
Bob Gray.
Bob Wright. Okay, Bob, thank you, just for the record.
Bob Gray.
Bob Gray. R-A-Y.
Okay, so on page 23, there's equation 2.1 and equation 2.2. Equation 2.2 is from Moon and Spencer, I believe. And that equation has a lot of typos, not a lot, has typos in it. That's why I say very careful editing of the book would go a long way, I think. For example, I don't know, Franklin, you can put up page 23, equation 2.2.
This is Bill Lucas. I think I've corrected all those things in my copy, but the problem is there is an original copyright still in effect. And so the patent office gave a 96-year relief to all the patent holders. And so it will be after my lifetime before it expires. But yeah, I have corrected as many of those as I can. And,
just wanted to point it out, make sure everyone.
Yeah, this is not my version. This is the original version. Did you see that? See, this wasn't my copy. This was someone else's copy of the book. And so they didn't correct the typos, but they did fix up some of the diagrams.
Yep, super.
Yeah. But if you want to send me an email,
by the way, which you've just scrolled through, a bit of a nuisance that they're oriented 90 degrees. A bit difficult when you're looking on a screen at it, because it's showing the fundamental differences of the various types of electric field depending upon origin. Just a bit of nuisance. You need to scroll, turn those around.
So did you have some other observations, Ian? So we've got, I think that's up to 4. So you're the last one being that this really hasn't resulted in any fantastic free energy for everybody.
Well, you might have lumped the last 2 into one. I had 6, Franklin. The first was about the non-electrostatic nature of V cross B and the shielding. The second was the flux cutting versus flux linking. The third was the gravitational force being the difference of the push and pull of the V cross B fields on the electrical constituents of atoms. The fourth was that you can negate gravity by putting in the opposing B cross V. The fifth was that you could tap any gravitational field for free electrical energy by capturing this B cross V. And the sixth was the one I mentioned earlier, that he says, when viewed correctly, it is compatible probably with SRT, but it isn't compatible apparently with GRT.
He had said something about relativity. I think I missed that.
But he's not talking about GRT, I think.
Well, towards the end of the paper, he says, just one short paragraph, as far as I can remember, it is frequently asked whether these theories are in conflict with relativity theory. It may appear so with regard to the special theory of relativity, insofar as it is interpreted by current relativists, but when viewed correctly, it is believed that it isn't in conflict. However, there does seem to be a contradiction with general theory of relativity. It's only about 4 lines, I think. It says that somewhere, if you can find it.
By the way, he's not the only one who says that. That one of the inventors of relativity theory, Henri Poincaré, said the same thing, but he made his arguments based on logic. He said that you couldn't have two theories with the same kind of, two fundamental theories with the same kind of force, like 1/r² type force. He said you couldn't have two fundamental theories using the same fundamental constants, like C. And since general relativity theory uses C, it also uses G, and it has a non-relativistic version of 1/r² for the force of gravity. All of those things show that it can't be a valid theory if electrodynamics is a valid theory. And but since they're using the parameters of electrodynamics and the 1/r² of electrodynamics and that kind of thing, Poincaré argued that the current versions of quantum theory, theory of gravity, special relativity, general relativity, they are all invalid, and they could be fixed by just doing a more complete version of electrodynamics. And so that shows you the kind of arguments. And that's why the scientific method was changed, so you couldn't falsify a theory using arguments from logic or medicine. And so that's why today the scientific method does not have a role for logic. You don't ever falsify a theory because one of its fundamental assumptions is known by experiment to be false. That experimental result is not allowed to falsify a theory. Only the predictions of the theory, if they don't agree with the experiment, can falsify it. But then you can invent dark matter, dark energy.
Okay, Bill, how about take Maxwell equations and take full time derivative is a partial one? You will get everything here what Hooper has been come up with. So, I mean, you're referring to Maxwell theory, but also saying that if something is to be about to be modified, extended, or whatever, then it is, right? So,
well, Maxwell's equations are incomplete because they only use 4 of the 6 empirical equations of electrodynamics.
But not only that. They are not using full derivative. When you use full derivative, you get at once both the Lorentz force and this Hooper's force, right? And the Hooper's mechanism and everything there. The convective components in the fluid and everything. And Hertz did that, and Phipps proceed after him. And Phipps also analyzed this Testatica generator. So, I mean, we have to get back, and then really kind of having that in mind. The special theory of relativity has not to be involved at all. Lorentz transformations has not be Lorentz and Poincaré, whatever. They should not do anything of that kind if they read Hertz reformulation of Maxwell's equations, and we are referring to them all the time, And that guy who died too early, he got forgotten, right?
Well, first of all, you got to remember that when Isaac Newton started out working with combining the axiomatic method, which is basically logic, with the empirical or scientific method, he put down the first time the rules logical procedures to follow that would give you the best theories. And that one of the rules was when you're working in a field like electrodynamics and you have empirical laws that appear to be independent of one another, you use them all simultaneously, the complete set, not a partial set, the complete set. And when you do that, you take the 6 empirical laws of electrodynamics and you solve them simultaneously. You can't do it in terms of a vector potential. You can do it in terms of an energy potential. And what happens is instead of getting a version of electrodynamics with terms, let's say in the force law, that involve radial and velocity terms, you get radial, velocity, acceleration, and DADT terms because you use the complete set of the laws of empirical
Okay. Did you
Well,
use?
let's not
Okay.
get-
Okay, Bill. Did you have you used the Hooper? Had you used the Hooper experimental results as input to your theory?
Yes, you can, because when
Right.
you,
Did you? Yeah, you did, right?
explain the force of gravity appears to be due to the vibration of multipoles, and they are spherically distributed in atoms.
So you
the
you
one
are sure
term-
that
the one
you are.
term that doesn't cancel is the V cross B term. All the other terms in the electromagnetic force cancel out with spherical symmetry, and this one that doesn't is what Hooper identified that can't be shielded as the source of gravity, and he was right.
Yeah, okay, but it can be also done by consistently going with the vector magnetic potential with divergence non-zero, and going also, as I said before, with the S field as Van Flanders did.
No,
right?
because you violate the laws of logic, which says you should.
Which kind of law of logic?
The
What?
ones that Newton did when he showed.
Newton, okay. Newton has been the biggest culprit of the conundrum in the physics. If you would like to know about that, please read my papers and see my presentations, you know.
We don't follow Newton's
Why are you going back to Newton all the time? He is the biggest culprit of this conundrum, right?
No, you've got it wrong.
Yes, he is. No, I'm not. Yeah, okay.
That's the idea. You can see.
When you when you remove the mass as a central category in physics, you are really on good positions, right? Otherwise, you have to go with dark matter and everything else.
With this method, you define what charge is, you define what mass is.
What? There is no charge. There is no static. Nothing. There is no static. Anything is not static here, right? There is no static charge. There is dynamic flow that is interpreted and experienced as a charge, as something that also Newton had gave his imprint, you know, by his wrongly established force of gravity. The same happened with the Coulomb force, and then this guy, Dirac has to postulate magnetic monopoles because what? Because there is just kind of static charge. There is no static charge. Everything. Or everywhere you have both electric and magnetic components, and exactly those 3 components that this guy Hooper gave, you know. So if somebody is going to make theory, has to cover that. Maybe reformulate, put a different kind of perspective, whatever. But you know, we have not relied on Newton, except on his unpublished works, but he was talking about anti-gravitational force that is actually proportional to 1 over to the third.
Well,
and electrodynamics gives you these forces, electrodynamically, fluid dynamically, gas dynamically, gives you these 2 components as basics one that seems to be present on all scales. If you have that in your theory, you are fine. If not, still not complete. Yeah. Thank you.
Anyway, you should read my book, The Universal Force,
yeah.
Volume 1, because I give a proof based on logic that the electromagnetic force is the universal force. I derive all the so-called forces in nature from electrodynamics. I get a better version of each force than the current version that's accepted. And furthermore, you have the simplicity. You know, instead of having 4 fundamental forces, you got 1. And you can explain nature better.
Yes, sure. But you still should not have... you don't have a right to really claim that it goes best and the only one. There is nothing static, nothing kind of vibrating in the pretty much kind of naive wave that we are kind of looking into the waves or oscillations, vibrations, and so on. So only movement, and then you can say, okay, this can be kind of vibration or whatever. I can just model it by that way and so on. But nothing static, nothing just vibrating, just kind of oscillating by itself.
All right, let's get back to the original paper. So we've heard a lot from Slobodan and Bill. I was wondering, did someone else do the homework and read the paper? And do they have some, maybe some points that maybe were missed by Ian that were interesting?
I don't know what was covered earlier. I wasn't able to join earlier. But I found what was interesting, if I can find the page again, he's identifying very early on, on page 3, says that there's 3 kinds of E fields. One, by virtue of their positions, these are the charges, virtue of their velocities, and virtue of their accelerations. To me, that sounds exactly like Weber's electrodynamics.
Yes.
And then if you go, as I say, to that page 22, equation 2.1 and 2.2, I'm not sure that I see a significant difference between those equations. 23. 3. The reason is that I don't see a difference is because equation 2.2 from Moon and Spencer, the middle term is Ampere's current force. And you know, if you integrate that around any closed circuit, you get V cross B. So essentially 2.2 to me is the same as 2.1. If you are talking about a closed current loop, and the closed current loop generates the magnetic field.
So you're talking about on page 23, I see a equation 2.2.
Yes, that's Moon and Spencer with some typos. But that middle term is Ampere's force equation between two Amperian current elements. You integrate that around a closed circuit, then you get a V cross B term.
I'm impressed you can find a typo in that, because that whole equation looks like
the
Greek to
typo
me.
is instead of a capital D, it should be an A sub R. And on the bottom, the denominator, it's, well, it depends on how you want to interpret it. R vector squared is just R squared.
No, but there is vector in the numerator, right? There is vector in the numerator already. So
Yeah,
R to the first degree over R to the third, right?
Yeah, that D sub R vector should be an A sub R unit vector.
Yeah, but he did not use unit. He just divided vector by.
Right, so it depends on how you want to interpret the.
Yeah, okay. Should be without vectors down there, right? In the.
But otherwise, it looks
nominator. In the denominator, there shouldn't be a vector sign, vector arrow.
Right. But to me, it's the same equation as equation 2.1. If you're talking about a closed current loop to generate the magnetic field.
Yeah, well, isn't that the whole point of this? Is they're showing that 2.1 is equal to 2.2? Because their thing on the left-hand side is exactly the same.
I think the point was that it's different. Moon and Spencer are not talking about fields, whereas Hooper is. But I say that's the same.
It all looks the same to me. Actually, honestly, it all looks like Greek to me.
Okay.
I'm just impressed you could find understand the equation well enough to determine that there's a typo. Because I think those kind of things happen all the time, and then that just leads to garbage in, garbage out. People don't realize it. That's the problem with equations. So how about someone else? I'll give someone else. I open the floor to someone who has not spoken yet. I'll give them 5 seconds. Dead air. Anybody? All right. Well, I had comments. I was looking at that whole relativity thing there. So there was something that he did say further down here about a charge that's sitting on the Earth. So he was saying that